So tonight we are going to talk about feature selection and identify. First we'll talk about identifying. No, nothing's working tonight. There it is. Thank you for sending the screenshot. And then we'll talk about feature selections after identify. Identifying objects is just what it sounds like if you've worked with ArcMap, which I think you all have, and you use the little I button to identify a feature. We will see tonight how to mimic that behavior in code, and that's is used extensively in Lab 4. But we'll talk about the various objects and interfaces that are used for an ArcObjects identify and go through some examples, hopefully. So we'll start by identify is another one of those strange ones where there's a lot of different related interfaces that you need to use. And on this screen here I have some of the key ones. What the base or the core most important layer for identify is identify. It's an interface. That's actually two capital I's. And it's castable from feature layer. So you get to the feature layer, then cast the feature layer right to identify to use it. And we'll see some examples of doing that. Identify, well, we'll see this in a slide or two, has a method called identify. It's kind of weird looking identify.identify. It returns some of these other interfaced objects that help us step through what we found. There's feature identify obj, short for object, returns an array of any objects that were returned. Now it could be more than one object if they're overlapping. Often identify only will return one object, but it can always return more if you clicked in an area where the more than one object overlaps. There are two similar objects that we cast back and forth with identify object and row identify object. And I'm saying object that they are all just obj that are related to feature identify object. And I've been talking about this, I've hinted at this a couple times, including last week. Identifying requires direct map interaction. I don't think we've done many or any tools yet that do. Like when you click the I button, nothing happens until you click on the screen. In a very early slide in the class, it may have even been the first night or the second night perhaps, we learned about the difference between buttons and tools. And from that point on, we've used only buttons. When you click a button, something happens immediately. Identify works with a tool. So when you create an add-in, we've always clicked button. Now we're going to click tool. Because Identify will work with an ArcGIS tool. Another thing that we've talked about a little bit, but not much, now we'll get into more detail, is the mouse down event. A little bit of review on a button. The event is on click. You've been using on click event the whole course. You click the button, something happens. Well, now because it's a tool, nothing happens until you click on the map. And that event is called on mouse down. So when we create a class for our new tool, it doesn't automatically add that. So we have to type protected override void and then add an event for on mouse down. I'm going to try that now. I'm going to go in ArcMap add-in. I'll do it in ctemp. I just realized I'm still signed in as Torsten, who doesn't have. Torsten was signed in when I came in, and he doesn't have any access to the folder. So notice I picked tool. Took a picture of Jack Dangerman. Why not? I'll add some references. So notice there's an on update, there's no on mouse down. So I'm going to type protected override void, and notice it's already going to give me the protected events to choose from, and I can just double click on mouse down. Well, let me change that text. That's really small. I have it set larger on my laptop for you. That's still smaller, even though it's a... So now we have our on mouse down event. Nothing in it yet. But again, an on mouse down event is required for a tool. And the event fires when the user clicks the left mouse button somewhere on the map. Before we go further though, let's look at an example of using a function to eliminate duplicate code. We'll take a step back. Often we're searching for a particular feature layer. Like you have a set of layers in your map and you want to find parcels, you want to find states or counties. you'll do that in Lab 4. Rather than write code to do that every time, we'll write a function. And as I wrote here, extra methods like this that could be used in multiple places could be put into a separate code file. So I'm going to go to Visual Studio. Right click and say add new item. I'm going to click code under Visual Studio items and name it a code file, and I'm going to call it helper. You could call it anything you want. Helper.cs. Let me see here. And so now in the table of contents I have this empty helper CS, and I'm going to add some using statements. That we're going to use. So once again, we are going to write a function that where we'll give it a name of a layer. It'll search through your table of contents, find the layer, and return an iFeature layer for you. I need to add namespace, the name of the project. I should have picked class, so I wouldn't have to do this. So this says that the helper is within the namespace of this project, which is identify1. And I'm going to add a class called helper. Which is, I should have actually picked class, so it would have done all this for me. So it's going to be a class within the helper.cs file named helper, and I'm going to write a function here to do this. I'm going to start that by typing public static. And this is a review of functions from February, maybe. So here's my function. Okay, we'll fix that. So we added public static, meaning it can be called anywhere. We're going to name our method. The method needs a name, and I call it findMyFeatureLayer. The method returns an iFeature layer. So we're going to call this. It's going to do some stuff that we'll add in a minute. It's going to return an iFeature layer. So that goes there. And we're passing into the function the name of the data frame and a string representing the name of the layer that we're seeking. So that's an explanation of that first line. I don't have it in the screenshot. Okay. I'm going to have a for statement to loop through every layer in the data frame. So here's my for statement. We're going to initialize it with an integer x starting with 0, and we'll go through as long as x is less than inmap.layerCount. So in other words, the number of layers in the data frame. And we'll increment x by 1, hence the x++. I'm also going to declare within this a new layer called temp layer. Okay, so let me explain. So here, I think I did explain before, I'm looping through every layer in the data frame. And in each iteration of the loop, I'm testing, is that layer's name equal to the name that was passed in? Well, if it is, that's what I'm looking for. I'll set my flag variable to true, and I'll set a variable called temp layer to grab that feature layer. So it's going to loop through, and do this. After the loop, I test again. Remember, is found started out false. And if it never finds the right name, it'll stay false the whole time. If this is set to true, we found our layer, and the function will return that particular layer. Otherwise, send a warning message. So here's our function. And that's all we really need there. Any questions? So now we're going to go back to our mouse down and get the active data frame like we always start out with, or almost always start out with. So PMAP is the active data frame. And we'll use a try catch block to see if my function works. We're going to look for the layer called counties. Because my MXD has a layer called counties. So I'm going to initialize a variable here, and remember now we're not in the helper that I wrote, we're in the tool. I'm going to call the helper. You can call it as a namespace, just like we do ArcMap and other libraries. I can say helper dot, and there's my find my feature layer that I wrote. It recognizes it for us. And it even recognizes that I wrote it, so it's asking for in map and in string, the name of the layer we're looking for and the name of the data frame. And in this case, we have the name of the data frame from a couple lines above PMAP. And I had mentioned that I'm looking for a layer called counties, so I'll pass that string in. Add another using in here for system Windows Forms. So that if the try block doesn't work, we couldn't find counties and it's going to bail out. So now, as I warned you, the identify process, and if you've done Lab 4 already, you know what I'm talking about, has a lot of different interfaces with it. So I wrote in the slide, set up the various identify related interfaces. And the first variable I'll set up I'll call PID, and it'll be an identify, which I had mentioned in the slide at the onset, that we can cast from a feature layer. So we'll take the county's feature layer and cast it to identify. Oh, what am I doing? That should also be identified. That's the problem. I'm also, next step, and I think I'm missing a reference, I'm going to set up a point variable. Yeah, that's in geometry. We go to ArcGIS reference. I forgot to add geometry. We're going to create a point object. We'll see in a few minutes how that's going to be used. We're going to create an array, iArray, that we're going to use to store variables that are returned. And I'm going to create this array, no pun intended, of different identify objects. And we're going to set up some interfaces to get to the fields. I don't think we've done that yet in the course, I can remember, so we can get at the fields in a data set. So rather than just getting the featured layer of the data, this is how we're starting to see how you can actually get access to data in a specific field. You can certainly see where that would be useful. So P fields represents a list of fields in a data set. A feature actually represents a specific record in a feature set. So if you have the shapefile counties, the feature Erie County is a specific feature, and that's the interface that we're looking at there. Next, we want to, if you think about identify, so far we're missing some important information. Where did the person click? We haven't captured that yet. And as I said, I don't think. Let me take us up to that slide. So these slides are what we've been looking at now. Now we're on slide 11. It might be 12. This may be the first time we talked about this. So this code you'll use quite a bit, not just for identify, for anything with a tool. This is how we get what spot the user clicked the tool. We use IMX application, and then on that there's something called a display, which represents your screen. And then, I won't go through the whole, especially if this may not work, depending on the computers. Display returns the screen point, in other words in pixels. It will return something like 20, 30, which is not a location on a map, it's a location on your screen. To remedy that, we need a class called display transformation. the display transformation class knows where the map is showing. It knows where they clicked on the screen. It takes the screen point and converts it to a geographic coordinate. So we will need to use display transformation. And then that will create a point in geographic real-world coordinates, not screen coordinates. And we can pass that point in to be identified. One thing that I've noted here that is important, when you're identifying a line or a point, and we're not going to get to that level in this course, but you want to consider, instead of using the point, buffering it as a polygon, because otherwise, if you're passing in a point, the user would have to click on the line exactly, which is impossible. If the user goes to identify Sheridan Drive and is 1/10 of a millimeter off of Sheridan Drive, the identify tool won't work because they didn't click on the line. When you identify features in ArcMap, there's automatically, and note that's why I have all polygon layers to make Lab 4 easier for you, so you don't have to worry about this. When you do it in ArcMap, it automatically has a tolerance behind the scenes, so you don't have to worry about that. But when you're coding, that is a problem, because no one will ever click exactly on the line. Even if you're, 1,000th of a millimeter off, it's not going to find it. That goes for a line and a point, not a polygon, because you're clicking inside the polygon. So it doesn't matter in the polygon exactly where I click. So what we do in that case, and again, you won't have to worry about this for the lab, but it's worth mentioning, is you buffer, and there's a iTopo operation. I don't think we covered that anyway. I think I mentioned that. You would actually use that in this case. You would take the point, use iTopo operation, buffer it to make a circle polygon, then use the circle polygon to identify. So then you have the tolerance. So that's something that you would need to address, and that might actually come up if in your lab or your final project idea you want to use something like identify on a line or a point. That would be the remedy. Then you can set the buffer to a specific distance. You might set the buffer to 500 feet, 10 miles, it depends on your map. That makes sense? So again, that's extra information, won't be needed in the course unless you need it in the final project, but I think it's worth noting for your ArcObjects career. So I'll just type what we were talking about. We need IMX application. I'm going to call it PMX app. If you remember, we don't use it that often, but the very first ArcObjects lecture, we talked about document and application being the two top level things, where the MX document relates to your MXD. That we do a lot. The application refers to the Open ArcMap application. You don't use that as often, but here's a case where you will. So I'm going to cast to IMX application because that's where the class is on. And then it's just ArcMap application. If I didn't cast, it would return it on the iApplication interface, and iApplication doesn't have the display classes that we need tonight. So now that I've done that, I can set the point that I created above by doing PMX app display and I think I am missing another reference. I'm bad about that. There's an ESY ArcGIS display. I'm real curious to see if this is actually going to work after going through all this, given what others have found on the lab with the computers. And on display transformation, the method is toMapPoint. Now I'm scrolling back up. How do we get the screen point? Remember when I first added this? Method 15 minutes ago, I didn't type that. Because it automatically put this in here, this line, base.onMarks down art. the argument gets passed in, and it's arg is of the class mouse event args. So hidden in this arg object is the screen location. So if I scroll back down, I can simply, the arg has methods x and y. So I do arg.x, arg.y. But again, that gives us the screen application, or the screen location, not the map location. So now, one more step on this before I go to the next slide. Oops. This is where the real identify occurs. PID, the identify from above, with the method identify, and we give it the geometry P point. This is the spot where you would use the topo operation and buffer into a polygon, and you'd put the polygon in there instead of the point, if you were so inclined. So now, let's look at the results. So we had that I array. Oh, yeah. So I did the identify and put it into this variable called PID array. If it's not null, objects were found. If it's null, it didn't find anything. You click outside the boundaries. I start clicking. So on the interface, so I click out here, it's doing identify, it's returning a null object. I didn't find any features. When you click somewhere and it comes back with the results, that's found in this IID array. So I'll have an if statement, if PID array not equal to null. That means that there are features, and we'll put all the code into that if block. Make sense? To help us with this process, I'm going to create two integer values. And now I'm going to loop through the list. It said PID, this is a list of features. Often it might just be one feature, but because it might be more than one feature, it returns it as a list. So I'm going to have a for loop that starts at 0, goes up to the length of the array, and increments by 1. See, where this for loop will loop through those items. So the very first thing we'll do, I'm sorry, there's a lot of different interfaces. I'll use I feature identify object casted from this statement. The ID array has a method get element. We will give it an index number. It will return that particular feature in the list, in the array, and cast its iFeature identify object. That'll come in handy in a few moments. we can also cast to just identify object, and the reason I do that in this screen is so I can take advantage of the method flash on the identify object interface. So flash lets you simulate. Notice when I click on a county, see how it turns, it flashes on the screen. The flash method on identify object lets it do that. I'm also going to cast to the third one here, row identify object. And that's perhaps the most important. So I've cast it over to row identify object. The row identify object has a method called row that will return the actual feature. It will return the data of the feature. Maybe is a better way to put that. So row identify object may return the shape Pennsylvania, but the row will return all the data in that particular feature into p feed, which was an I feature if I scroll up. So now we have as I feature that actual shape, that actual GIS record, the individual one that was clicked on. A feature has, I alluded to this earlier, a property called fields, which is an I fields. It's just what it sounds like. It's a list of fields that are in that shapefile. And we find field. This is a little tricky, not too bad. We find fields and use fields in the list through an index, not the name of the field. So in other words, when you retrieve a value of a field, you don't say find the field name, you say what's the index of the field. So to get to that, pfield has a method find field where you can pass a string. And so what's returned here is the index position of those two field names, because the index position is what we're going to need going forward, not the names. I wish they would simplify that and just let you pass the name. So in other words, if I click on a county, name is in the 4th position, so it's the index will be 3, 0, 1, 2, 3, and the index for state name is 4 because it's the 5th field. And you'll see on the very next line I'm going to type why I need that. So the very next line I'm going to put a message box to show results. And then finally, back on the original if statement, if the array was null, I'm just going to put a message box that says, no features were found. So see, when I get the value, a feature has a method called getValue to get an actual attribute value. Notice I needed to give it an index, not a name. So that's why we went through the trouble of finding the index number. So getValue3 will return the county name, not getValue name. This ought to be interesting. Let's see if it works. It may not, because I don't think this machine's any different than those. Same problem. Because even before we went to choose this add-in, just that trying to open the customize window caused it. So we're not going to be able to see anything working. I could show it working if the monitor cable was here. Let me just try this way. Well, it worked that way by not using debugging. Were you able to do where I actually clicked the build-in, clicked the add-in to install it? That will be more of a pain to try and debug. It's so much easier to do it the first way. But if you actually go in and run the add-in to install it, and I actually didn't even do that and it showed up anyway, this seems to be working. Because when I went to commands, it's already, even though I got the error, when I went back it was there. I dragged it in and it seems to work. I wasn't expecting that. And you'll also note when I click on a county, it flashed, see that light, and then it comes up with the message box I created. So that might be a way around this while they attempt to figure out what happened over with the upgrades that they ran. That still might not work on every machine though. It happened to here. You know, also the pain about that though is if you do that every time you do it, you have to close ArcMap and reopen it. We all know that takes a little while on these computers. Do you have questions?
Didn't even open ArcMap on this one.
What? It wouldn't
Didn't even open ArcMap at all on this one.
Really? What is it?
Program is blocked by group policy.
Really? Remind me to.
That's not even trying to.
Just opening up ArcMap. Would you mind also letting me a screen capture? I have another screen capture to send. Hopefully no one else has had that problem. They didn't have that problem. And this computer, ArcMap won't even open at all. Hopefully it's isolated to that machine. We'll send some messages out about these things. On Activate is another event on a tool, and that's a location at which we can choose a cursor. So within on Activate, we can set cursor property using a bunch of standard Windows cursors in system.windows.forms. There's a namespace called cursors. So I could type in another protected override void on activate. That gives me this base class, the base object. It has a property called cursor. There's a class cursors within system.windows.forms. I had already added that in my using statement, so I can just say cursors, and I can pick from a variety of default Windows cursors, like for example cross. I'll build, reinstall the add-in. I'm kind of curious also to see if this works a second time. Oh, we're saying okay, good. Well, at least I'm still gonna contact them about the other issue, but there's a workaround, so we can still work. So notice the change. Notice now with that tool activated, I have a cross as a cursor because of that onActivates code. Any questions? I'm going to close that before we move on. Identify, I'm glad about that. Identify can also be used to label tagged objects. And in some of this discussion, we'll review some of the interfaces that we talked about last week. So we're going to work with, remember we talked about elements last week. We're going to work with elements, and specifically iText element, to create a graphic with the county name when the user clicks. We also talked about the iGraphics container being a list of graphics on, or elements on a data frame last week. And we talked about an envelope being a rectangle that's the smallest spatial boundary of a feature or object. So if you have a country, it's not a very good China. The envelope is the smallest rectangle encompassing the geographic feature. This might even be a review slide for us from last week. A text element inherits from the abstract element class. An element can be a piece of text that you can select and move around. It can be a point, line, or polygon, graphic that you select to move around. But there is a specific subcategory of element that we're going to talk about in this section called a text element, which has properties specific to a text element, like its text, its symbol, what font it is, and so on. Things that wouldn't apply to the points, lines, and polygons. So we'll redo the identify example, but instead of a message box, we'll add a text element to the map where the user clicks the name of a county. So this, I think, it's just a review of what we just did earlier. But instead of that last step where we post the message box, we're going to replace that with code that will add text to the screen in the location clicked. So I'm going to comment out the message box and add this other code now. I'm going to create a text element object. I think you call it PTXE. And it's a new object of the text element class. and then I'm going to cast it to PEE, so I have the same object as a text element and an element. And we talked about, you might remember last week, talked about three things coming into play: an element, a symbol, and a location. We have an element, now we're going to create a symbol. So we have a new text symbol class. We use the I, and this I mentioned this gets a little bit, well, I font disp is missing. Let's that's right. I didn't system.drawing. I should have thought of that. I think that's the one we need. Nope. System display. Oh. Standard OA. Somewhere I'm missing something. Missing on this. remember having to do that before. Okay, I had to add the standard Olay library to my project. Not through ArcGIS reference, but through add reference and .NET. It's a .NET library. And then I added it using standard Olay, STDOLE. Now, there's my font disp. Sometimes the smallest thing takes all the time. I'm creating a new font object, setting it to standard font class. Then casting that. So it's an iFont disp display object. Well, it just isn't working. Let's just move on. Something's not. I think it'll just take the default font anyway. Never had that problem here before. And we talked about colors last week. And this was one of the ways we created a color using the Windows color translator. So we have the symbol minus the font, and we have the element, but we still need the geography. We still need to tell our map where the piece of text will go. And actually we haven't told it what the piece of text will be yet. So two more things to resolve. There's a property text on the text element, and what we'll do is we'll get the name of the county. We retrieved that earlier. Cast it to a string. And luckily we already have p-point. Remember that, where we have the spot the user clicked on. So now we're getting closer. We need to add it to the graphics on the map. Remember there was that graphics container. And we can get to that from pmxdoc activeview.graphics container. We add the element. We add the element using the iElement interface, PEE, not the iText element interface, TXE. And the 0, remember, makes it on top. And then because we changed the view, we need that refresh statement. pmx.doc activeview.refresh at the very end of our code. I'm going to go into my add-in, double click it to install it. See what we come up with. Oh, there it is. So there's the, it's grabbing the name from the identify result and creating the text element and adding it to the graphics container. Not very quickly, but it is. So now we learn not only how to identify, but how to add text to the map. Any questions? So that's the section on identify. The next thing we'll talk about is feature selection, if there's no questions. And this screenshot here shows some of the things we can do with feature selection. Feature selection is an interface we'll use for that we get from a feature layer. We cast from features, just like we casted from feature layer to identify, we can cast from iFeature layer to feature selection to get access to selection properties of the feature selection, what colors it's selected with and so on. And also its property called selection set, which lets us get a cursor. We'll talk a lot more about cursors in the last couple classes of selected features. So now we've kind of seen how you could loop through features. Not that much, a little bit. Like say loop through all the counties. Now you can use these interfaces to just loop through selected counties. So this is our first exposure to working with selection sets. So we'll start by writing some simple code to access the selection set and see how many features get selected or are selected. And this would be a button. I'm going to right click, add a new item, a new ArcGIS component. So in the click, I'll steal the top two things from the last mouse down event. We'll start out by getting the active data frame, and for simplicity's sake, we'll get just the top layer in the table of contents. So once we have the top feature in the layer of table of contents, we cast it to iFeature selection. Here we get PFS, and we can get the selection set, assign it to PSS, on the very next line. So now we have access to the selection set in that particular layer, and the selection set is the list of selected features. And we'll post a message stating how many are selected. Let's build that. So there it went through the selection set, got the number of selected features, and that I think I have 20 counties of Texas selected here. $13 and so on. Any questions? We'll take a step back and talk a little bit more about cursors, these cursors that I keep mentioning. A cursor, as I mentioned a couple times, but to define it again, a cursor is an object that represents a specific set of records in a table. And it can either be a cursor if it's just a table, or you'll see it as a feature cursor in other cases, where a feature cursor is specifically related to a table or GIS data set that is of feature, a shapefile or geodatabase. The cursor is not tangible to the user. It's a set of data stored in memory. So if you write some ArcObjects code to create a cursor, the user doesn't see it. It's something that is in memory. It can be created through a variety of methods. You can retrieve all at the simplest form of a cursor is just to retrieve all records in the data set. A cursor doesn't have to be a subset of records. It can be a set of records via selected set. So in other words, we could take the code we just wrote, and rather than just say, oh, there's 20 counties selected, get a cursor of those 20 counties. Or we can do an attribute or a spatial selection to create our own cursor. You know, select every county that starts with the letter E, or a combination of all of these. Mostly I'm talking about using a cursor to set up and view data, but we'll also see how you can use a cursor to update existing data or add new data. In Lab 7, Create our Habitat Point lab, you will, I might have that as Lab 6 this year. You can use a cursor to create a new point in a shapefile. The main interfaces you'll use are iCursor and iFeatureCursor. iFeatureCursor, as I mentioned, is specific to a table of GIS data, where an iCursor would be used on tables and whatnot. We'll also learn how to create attribute and spatially based cursors using iQueryFilter, which we can use for an attribute query, and iSpatialFilter, which we use for a select by location. So it's roughly analogous. I closed it. But in ArcMap, when you go select by attributes, you're using an iQueryFilter. If you go into ArcMap and choose select by location, you're using an iSpatialFilter. Another diagram here shows how dataset objects relate to each other. So here's how feature classes and tables, which we've already talked about, is a little hard to read. It's really hard to read. Maybe it's just my eyes. But the main point here is the feature cursor and cursor come from a table or a feature class. And then you can use a query filter to build them. That's a little better. So iFeatureCursor is a child to cursor. So the iCursor is a more generic interface for all types of tables. You know, whether it's a GIS data table or just an Excel table or DBF or a non-spatial data set. And iCursor has methods like insert row, which you would use to add a new record, delete row. Those of you that are in CIS and in computer programming and data management will be maybe more familiar about these type of things than core GIS types. But in a database, you can, they call it CRUD sometimes, create, read, update, or delete are different things you can do to a database. You can insert a new record into a database, update an existing record by changing attributes, remove a record from a database, or just, so I don't have this listed here because it's not necessary to put it in the method, or just select a cursor to look at it. These three methods all involve changing a database somehow, but select is another option where you're just looking at the data. iFeatureCursor has the same options, but instead of row, the method's named feature. Delete feature, insert feature and update feature, and they mean the same thing. So insert feature would insert a new GIS point, delete feature would remove an existing point, and update would change the attributes. As we'll see, I actually think that's next week, you'll see when you're opening a cursor, you kind of need to know what you want to do with it from the beginning. If you want to open a cursor with the intention of changing data, you would open it with update and not select. As I said, I think we get into that more next Monday. So one of the most common ways in which we obtain a cursor is query filter, and its iQuery filter interface. Another is spatial filter. I think we have a slide, I think that's the next slide. A query filter is a co-class. It's a creatable object that must be set up with a where clause before you can get your cursor. Where, that's another CIS world type thing where you, in SQL Server or Oracle, if you issue a database query, use something called a where clause. The where clause lets us specify the filter that we want to issue on the data. So the query filter doesn't have that many properties on it, and the most important property is this where clause string. We'll talk about that in just a second. So again, the query filter lets us set up a filter that will be used to produce our cursor. So in this example, we'll do this. We'll grab the first feature layer, but we'll ask the user to specify a name. We'll use a query filter to search for those records. Ask the user to name a county, and then I'm going to create a query filter to search for it. And as I said, it's a co-class, it's creatable. So we're creating a query filter class. I'm going to call it PQF, and I'm going to use its property where clause, and this is a SQL query or a SQL statement, but only the where clause part of it. For those that have used SQL Server Oracle, you can do a million other things with SQL statements. This is focused just on the select where clause that you would do in SQL Server. So the where clause is the field name. Like is a SQL statement that means this is a wildcard. The wildcard symbol is a %sign. So we're searching for not an exact match, but anything that is close to this. So if I type ER, it will find everything with ER in it. And so we need to attach this string to the actual thing the person typed with the percent marks around it, and single quotes, because you would put single quotes in an attribute query when it's a string field. So now we have our query filter. We'll get the feature class, because we'll use the feature class to do the search. So we have the feature class. If you remember, maybe 2 or 3 weeks ago, we talked about the feature class being the data behind the layer. And now we can set up our cursor. Feature cursor that I was talking about a moment ago. You can get a cursor from a feature class with the method search, giving it the query filter. We are recycling. I'll put true. And notice, we'll get to this next week, I use search. I'm already saying that I'm not wanting to update anything. This is a read-only cursor we're creating. I'm going to leave it search, but if I go back to the Visual Basic IntelliSense, notice that there's other methods. For example, update. If later in this example I wanted to use this cursor to say change the data, instead of search I would type update. I'm not intending to do that, so we'll use search. And an update cursor is slower because it reserves the ability to make data changes. So in any situation where it's a read-only situation, you should always use search. Don't open your data for reading if you're not intending to read it. It's also a little more dangerous. If something were to happen, that did happen to me once. Someone was running a program that opened the data for writing with an update statement, and at that exact moment a lightning struck and the power went out. Because the file was open for writing, when power came back on, the files that it was editing were gone. I'm not sure if that would still happen. That was a couple of years ago, but it's good practice to use a search or read-only search query if you only intend to read the data and not change it. So as I mentioned in the first cursor slide, what I'm doing here is just creates an in-memory data set. It's transparent to the user, but we kind of want to see the results of our work. So I will tie the cursor back together with the feature selections that we looked at a few minutes ago. So to do that, I'll go back to my feature selection that I did in the last example. And feature selection has a method select features that also takes a query filter. And the selection, and we enter the selection method new. We'll start a brand new selection. So we're using the same query filter to select these features. And what have I done wrong? Oh, I already. It's the same example. I already used that variable name. Oh, there's one. The third item is whether to select just one. I'm going to click false. I want them all. So this is actually two examples in one. I'm showing you how to build a cursor, but I'm also showing you how to use a query filter with a feature selection. Notice that it selected the Erie County, so it used the query filter to automatically do a feature selection. And I could there's only one county with REE in it. Reeves County, Texas. Who knew? Are there any counties with GRE in it? Well, there's a lot. So our first example of using a feature cursor and a query filter. Spatial filter, I mentioned a moment ago, allows us to create a feature cursor based on a spatial relation, not attribute. It corresponds to the select by location command in ArcMap. It inherits from query filter, but has a special additional properties only for spatial searching. For example, find all parcels within 1 mile. So the spatial filter has some additional options like geometry, what shape are you using selected, and spatial relationship, an enumeration that describes the relations to be tested. But notice, and this is something you cannot do in ArcMap, a spatial filter still inherits from it's a child of query filter. So you can have a spatial filter query that also has an attribute query. You can do it in one statement. You could say find every county, within 100 miles of Miami that starts with the letter M. You could do that in one code base in ArcObjects. If you built that query on ArcMap, you would have to it would take 2 steps. So here's some of the spatial relationship enumeration constants. You can enter in text format or the associated integer, like most enumerations. So for example, query geometry intersects target geometry is one of the spatial relationships. That's probably the most common one. So if my polygon is this, it would select China, and it would select whatever that country is, Nepal or India, because the 2 geometries intersect. So I think, I'm not sure we'll type through this, but I'll explain what this is doing. So in the example in the lecture, we'll select one county and use its shape to locate all zip codes in the county. So in the first part of this, and the slideshow happens to use Lampasas County, Texas. So I'm using my ArcObjects, or my helper thing that I did earlier tonight to find the counties layer and the zip code layer. I am searching for Lampasas in a very similar way to that I just built. So I'm building a query filter, name equals Lampasas. I do happen to know there's only one county named Lampasas in the whole country, and it's in Texas. So I'm getting the feature class of the counties and the feature cursor, just like I already did. And then this is something new. Instead of going to a feature selection, I'm issuing the method nextFeature on the cursor and assigning it to an iFeature variable. So that takes the first item out of the cursor, and I know there's only one because I know the county geography. And it assigns into iFeature the actual feature that represents Lampasas County. And a geographic feature has a property called shape that returns its geometry. So I retrieve the geometry from the feature into an iGeometry object. So I now actually have the geometry that defines the boundary of Lampasas County. In the following slide, so now I have the shape that I'm going to use for my spatial selection. So in this slide, I'm creating a spatial filter class object. I'm setting its property to intersects. That's the relationship, just like I drew here. So we're going to use that relationship, the intersects relationship. And I'm going to set the geometry of our spatial filter to the shape of Lampasas County that I discovered on the previous slide. That I discovered that I created. And then once I do that, I'm going to use feature selection, use the spatial filter in the same way to see which zip codes were selected. And we can see the result here. So every zip code that intersected that original geometry became selected with the feature selection. Is there any questions? It's slightly early. I don't know if you mind. There's not that many slides left, so if people would rather just finish up and finish a little early, we might be able to look at labs that are finished now anyway. I'll just go ahead and do that if there's no major objections. If someone really needs a break, let me know. We can take one. Doesn't look like it. So in the very last section tonight, and we'll pick this up further next week too, we'll talk about tables and fields. So we'll start the discussion about tables and fields and stop it, and then pick that up next Monday. So working with tables located in your data frame is similar to how we're dealing with feature classes. Just like a data frame has a list of layers, a data frame has a list of tables in it called in the iTable collection. And some of this we won't get into in too much of the class. Some of these slides are just for your information. We won't work with tables too much in the class, but I wanted to make sure that it was covered. So you can QI from IMAP, which we've used IMAP quite a bit, into iTable collection. And if you do that, instead of getting the layers, like shape files and feature layers in the data frame, you'll get a collection of the non-spatial tables, Excel files, DBFs that are in the data frame. Going from there, we could grab a table by a specific index, just like you've done. We could use a query filter, just like we've done, except you would use iCursor, not iFeatureCursor. And instead of using feature class, we would use table. So the analogy to what we talked about earlier is iCursor instead of iFeatureCursor, iTable instead of iFeatureClass. And instead of feature, the analogy is row when you're working with just a standalone table. So the methods, because they're so related, in fact, table is a parent to feature class. Feature class is a specific type of table just for GIS data. The methods are very similar. And then, 2 more slides and we're done, actually. I wanted to introduce how to work with tables. You won't do it that often in the class, but it's important to note it. iField and iField Edit are things we will use in the class, and this is kind of an unusual case. iField is an interface to look at, and I say look at on purpose, information about fields in an attribute table, columns in the database. So iField has properties like length, how big is the column in the database, type, is it a string or number field, and so on. It's read-only. So we use iField to just retrieve information about fields in the shapefile, for example. There's another interface called iField Edit that's write-only. I think when we talked about different classes, you might have looked up some things like this for the quiz. This is a very unusual case. You don't see that very often. You see read-write properties or read-only. This is write-only. In other words, I can use iField Edit to change the length of the field, but I can't use it. It can't see what the length is before I do it. So you're kind of going in blind, almost, so to speak. It's a write-only property. You don't often see the diagram with the dumbbell just on the right. And I think it's very strange how they did this. So when we're editing a field, and you're really only doing that when you add a field, you can't really edit existing fields in GIS data. I really wish you could. I mean, obviously, in so many other database management solutions, you can go to SQL Server and add a column and change its type. You can't do that at all. So when we talk about editing a field, it's usually, or always actually, when we're adding a new field. So you would use iField edit to create a brand new field that you would then add to a table. And so this is, to me, this is a little bit weird, but that's how it is. So for example, iField edit, some of the properties would be setting the name of the field, of the new field, setting its alias, setting its length. If it's a numeric field, what is the numeric precision? Scale is a similar thing. Type is enumeration defining the type. Is it an integer or a long integer? Is it a string or date or blob field for storing binary data, and so on. And so that's the lecture. So we'll actually finish a little early.